everybody, I'm Leia. And Linning asked me to come talk to you about fabric. Actually, she didn't even necessarily say actuated fabric. She just said fabric, which is a really dangerous thing to say to me because I could talk about all kinds of aspects of fabric. And I am, for today, going to focus primarily on actuated fabric and then also on body soft interfaces. So these are not necessarily all of fabric. On body soft interfaces are certainly not the only kind of soft interfaces. Actually, if you ever take my e-textiles class, warning, something I make the students do on the first day is we try to brainstorm as many possible things that are made of fabric. I say that they have to each say a new thing that somebody hasn't said before. And people will say all kinds of interesting things like, you know, couches and kites and tents and things like that. So there's a lot of fabric in the world. For this class, I'm going to talk a little bit about like fabric overall. And then in terms of like context and applications, I will specifically be talking about clothing, costume, like that kind of continuum. So this is the overall outline today. What's fabric? How do we do interesting technological things with it, which is it's a really loaded way to say that, but that's where we're at. We'll take a little break and then I'll come back and talk about like specific applications and like cool things you can do with bodies. So we need to start always. I think it's always really important to start with like just the base level definition. What even is a fabric? Because this actually is like not obvious. And apparently in English, we draw a distinction between fabric and textile and cloth. These have subtly different meanings that even as a field expert, I actually usually have to look up what the differences are before I like use a specific one in a talk. So I'm going to use them all interchangeably. So just, you know, to set terms here, what even is a fabric? And for this, I like to use this definition from Vanessa Sanchez, who's a friend of mine, just got her PhD, super cool person. And she has this great diagram in this roundup paper. If you're interested in textile technology stuff, the paper I linked to in the slide is super good. And she talks about fabrics as this kind of hierarchical material where the baseline thing is some kind of fiber. And then there's a whole family of processes that we can use to turn fibers into surfaces, into objects. And usually those objects are still sort of surfacey objects, like clothing, right? Like that might go on top of something else. So those fibers can be natural fibers like cotton or wool or silk. They can be synthetic fibers like polyester or acrylic or rayon. We have various processes we can use to turn them into threads or yarns. Thread and yarn, again, get used differently by different industries, might mean different things. We could also turn the fibers directly into a surface by like heat bonding them together, or there's other kinds of like enmeshment technologies like weaving, knitting. Once we have a sheet, we might cut it and then attach it to itself to make sort of three-dimensional shapes, or we might even make that three-dimensional shape directly in the braiding or the weaving or knitting or whatever. So there's a whole family of fabric technologies. Some of them are very DIYable. You may have even done a lot of these. Some of them are very industrializable. Sometimes the same technique can be done in both ways. So there's a huge family of things, all kind of related to these, like, okay, on the base level, it's a fiber, which means it's maybe pliable, it's soft, it's maybe breathable, maybe actually. Textile, the word includes non-breathable surfaces, like a sheet of rubber is still a textile, even though it might not necessarily be a fabric. And these things, you know, kind of merge together in these technologies. So this is big picture, like what space are we even talking about? You know, we're probably not talking about pasta in this talk, probably, but we are talking about a whole wide range of things. Okay, once you have a fabric, like what does it mean to be actuated? And like, what is that? How does that relate to e-textiles, right? Like, what is e-textiles? Oh man, I don't even know. And I teach a class on this. And actually a good friend of mine who also does research about e-textiles ran a whole survey about like, what is an e-textile? And they sent the survey out to a bunch of other professionals, you know, who work in sort of electronics and soft goods and the intersection between the two, about how they talk about their work, right? And so there a lot of terms came up repeatedly, washable, comfortable, flexible, and malleable. Like that's going to come up in textiles a lot. And then they talked about a lot of the contexts in which you might see these things. Clothing. Clothing's like a really obvious one, but also healthcare. Linen already showed a couple of healthcare applications, right? Like a splint or a medical surveillance, those kinds of things. So this is, again, huge constellation. What I want to talk about though today mostly is just like soft interactive systems. What's an interactive system? It's anything that has an input and an output, and probably some kind of processing between them. And so in this context, when we talk about robots, a lot of times input is going to be something like sensing, a camera or a temperature sensor, anything like that. And then a lot of times the output in a robot, as opposed to a computer, is actuation, which just means motion. Something moves in the real world, as opposed to some lights change on a computer screen, right? Or a graphic changes or projected image or whatever. So actuation is just the physical moving in the world. Personally, I kind of like to group even things like the temperature changes with things like actuation. I mean, it's not literally something moving, but it's still like a kind of a tactile effect in the world, as opposed to just like a graphic or image effect. Okay, so that's what I'm talking about. What am I talking about? Actuation. What do we need to do to get actuation? And this slide applies to kind of like all of actuation. And then I'll talk about like specifically fabric. All of actuation, you got two questions, but they're both hard. One of them is, how do you get some kind of force? And the other one is, how do you make that force interesting? Super, super simple case. Force, you got a little buzzer motor. Buy this for 5 cents, you hook it up to some power and it goes, bzz, bzz, bzz. It's a force. It's a little buzzing back and forth force. How do you make it interesting? I don't know. Stick a googly eye on it. Actually, this is a good way to turn a buzzing force into something you can see, which is kind of fun. Or like if you're going to be an actual haptics researcher, you can do all kinds of interesting stuff about like, multiple buzzers positioned around a body. This is some work by some colleagues in the HCII about feel effects, right? What is it like to be in a wearable that buzzes here and then buzzes here and then buzzes here and then buzzes here? Do you actually feel it as like a transition across your skin? Apparently yes. So that's an example of a very simple force, but the fact that they're sort of moving which one's on makes it interesting. Force, interesting. Okay. In actuation, like making motion, big motion, not just feeling a vibration. A lot of times the way that we make a force interesting is via something that I would call a deployable structure. That linen probably also has lots of other terms for, depending on sort of like subsets of this concept, but it just means that it's something where you have a structure that itself responds to a very simple force and makes it interesting. Okay, I'm talking in circles. Here's an easy example, an umbrella. You apply a linear force to it, just a single slide, right? And the whole thing unfurls, right? The unfurling motion is not an obvious result of the single linear slide. It's built into the way that the struts are arranged and that the tension membrane of the umbrella itself keeps everything in line. I didn't intend to find a GIF where the umbrella pops off, but I think it actually just kind of tells the story a little more even, right? This is like several motions happening from a single input force. A really like sort of famous and well-known example of a deployable structure within like textiles practice is origami structures. This is the Ori fold, right? That is such that if you just apply a single sort of outwards stretching, it unfolds itself on both axes. This is an auxetic material is the term for that. But again, it's about how the folds go together, that when you just do a simple motion, it makes it more elaborate. Okay, deployable structures. How does that relate to fabric? The umbrella one, I think, was actually a great example. That's fabric. And it shows something that is gonna be something that comes up again and again when you're working with fabric, which is that textiles are great at providing tensile force, terrible at compression. So a lot of times when people think of fabric, they think of fabric as weak because they think I can just push fabric and it'll just buckle. And like, okay, that's true. You can just push fabric and it'll buckle. I have some fabric on this table. you know, I just like this, it's like weak. But actually fabric is very strong. It's just really strong in this direction, right? It's really hard to tear. So fabric wants to be in tension, right? When I pull on it, it can be strong. When I push on it, not so much. Kind of comes down to how you arrange these things. And often you're going to need something that is good in compression. So in the case of the umbrella, the fabric constrains the ribs from going any further because it's very good at sort of pulling inward. But then those metal ribs are what balances out the fabric to make the overall structure. Okay. How to get some kind of force? Example, tendons. This is one of my favorite examples because it's one I do a lot. Because it's easy and cheap. Let me explain. Roboticists call this thing tendon actuation, which is just a bunch of extra syllables for what you might also call a drawstring, right? This is a paper, this is an actual published paper in the world where they say, hey, if you sew a piece of yarn across a piece of fabric and then you pull on it, the fabric's gonna crumple in an interesting way. You and they might have different definitions of what is interesting, but you can start to see, especially in figure D there, right? Where they say, hey, if you stitch it in a curved way, then when it crumbles in this kind of curved way. And this is really taking advantage of some, you know, the string. It's really easy to pull a string. It's really easy to get a fabric to crumple. This is great. And yeah, depending on how you put that tendon, drawstring, pull string, whatever, in the fabric, you might get interesting different shapes. So here's some things where the strings are going in different ways around these little just stuffed fingers, right? And it's three kind of excitingly different, I think. I mean, I would say this is my work. Excitingly different shapes out of just pulling one string. But because in this one, the string starts here and then goes here, you get this cool little S shape. Okay, Leah, that's maybe starting to be interesting. Is it an interface? I don't know. I mean, like with this, it's like, well, now you've got a crumpled piece of fabric. Like it's not really like interactive necessarily. And one of the big reasons this doesn't feel interactive is because it doesn't reset itself, right? You have a crumpled piece of fabric for forever now, unless you like physically stretch it back out again. So the other big consideration for soft interfaces in this sense is if you want to repeat the motion, if you want to do it more than once, which is kind of assumed for interaction, you're going to need some kind of restoring force. So here's these little fingers again. They're stuffed with different things. So this one's just like polyfill, like teddy bear stuffing. This one is styrene, like almost like a milk jug plastic, and this is a soft fun foam. So you can see that they all kind of return to how they were before I pulled the string, greater or lesser extent, right? A lot of this stuff you're kind of designing for how much you want it to do that. And with fabric, there is a trade-off, right? If you want something to be very springy and like end up exactly back in the same place, you're probably thinking about materials that are maybe a little bit stiffer, might get a little more out of the range of what you consider fabric. But all right, you got these things. You can combine them. You can combine them in interesting ways, right? Like this single little finger. I mean, it's cute, but it isn't really like a thing. Maybe, I don't know. But if you put two fingers crossing each other, you've got a gripper, and now you can write a soft robotics paper. That's all they're looking for. It's just a gripper. You know, you can make it into a little bunny. His arms can hug, and his ears go down too. You can use gravity to some extent as the restoring force. So in the lamp here, a large part of how the lamp goes back down is just gravity. Easy. Thinking about more like deployable structures, right? Like something where the structure itself is really going to give you like that interesting shape. Here's a slightly more complicated example, also, again, my own work, where the way that this fabric tube is pleated and embroidered, this is a process called smocking, makes the fabric really want to be in like a vertical tight tube. So if you pull it down with strings, it'll kind of unfurl in this way. But if you like come back up again, it'll kind of de-unfurl in this way that is following the lines of the pleating. Slightly more complicated. Okay, much more complicated example. This is a runway show from 2007, 2006, that's how fashion works. it's a little slow. And so I'm just going to show a little bit of it right now, but this video is in the slides. You can watch the whole thing. The sort of concept of this show is that the clothes are morphing through various like decades of fashion. So right now we're sort of seeing, I think, the like 50s into the 60s. I can't exactly remember how the story is supposed to go on this, but it is various silhouettes of fashion being changed amongst in these garments. And this is all 100% done with tendon actuation. These models are wearing a bunch of motors under their clothes. It's actually a little hard to find these like making of pictures because at this point it's a slightly old show. They do exist on the internet. They're mostly like really hacky and low res. Okay, this is a great show. Super impressive, lots of engineering, very, very cutting edge at the time. Also, this was one of his first like famous shows, and he's gone on to do a lot of like very well-known things. Okay, like I'm not gonna build that. That's like a lot of work. That's fine. Okay, it's fine. You can build something much, much, much simpler also. So this is some work by one of our colleagues where he's 3D printing directly on some fabric just to make little holes for the tendons to go through. And just pull on them. I'll show that one again because it goes kind of fast. So it's the same like cool, fun, elegant motion done in a much more hacky and DIY way. This is very, very approachable. That's why I love tendons. How do we get that pulling force? You got options. Like I said, you can use a motor. I love motors. Motors are good. I mean, it feels a little almost like cheating, especially if you see Linning's work and you see all these cool ways of actuating things that don't involve motors. Totally legitimate. Motors are fine too. Motors are really good if you want something that goes fast and reliable. So it's just a little motor. Makes the thing go. Very good. Like contractually obliged to tell you can use muscle wire. I don't recommend it. There's a whole separate rant, but you can. So this is this category of effects known as shape memory. There are materials, and Linning is totally going to tell you more about these later in the semester, I'm sure, that can be induced to change their shape, generally based on like a thermal effect, sometimes based on light. So one of the most well-known ones is this muscle wire. You can do a little bit of a tug. You can do a little bit of a bend. One that I like better just because it's cheaper is same basic idea though, shape memory, but this time in a polymer, rubber plastic essentially. I mean, think rubbery thing instead of in a metal. You can get sort of a similar effect out of nylon. Nylon also has shape memory. If you're clever about how you put a bunch of twists in it, you can get it to do tugs and twists and things too. This is also work out of our lab on the right there.
Yeah, is it by heat or
yes,
by light?
Yes. It is by heat. This one is by heat. And so this paper, the modifiber paper, is about integrating the twisted nylon plus a heat source plus a restoring force. So it's kind of everything all in one fiber. Like the underlying nylon thread is just going to do your shrink. But if you pair it with something that actually makes the heat, so like a resistive joule heating, run a bunch of current through something resistive. And you also pair it with then something, in this case, a silicone coating that'll push it back out again once it's cooled. Now you've got one assembly that can kind of do all the things. Great question.
Thank you.
Mm-hmm. And the third in this category, and you're definitely going to learn about these more this semester as well. I put this in my e-textiles slides because I'm just like, this is the cutting edge, this is the bleeding edge, which it kind of is. There's this category of liquid crystal elastomers, which again are, triggered by some stimulus, can do a sort of a shape change. These are not cheap like this is, but they do exist in the world, and so you can sort of like think about them in that way. Okay. So tendons and contractions, think about the deployable shape, and then you get that force somehow, a motor or a shape memory effect, perhaps. Another great category of soft interface stuff is inflation. Two main categories here, actually. One is inflating like a sealed chamber, airtight, relatively high pressure, I say, as opposed to the other approach is like a continuous blower. Think of like a bouncy castle, right? Where the surface that contains the air is actually full of holes, right? Fabric is known for its holes. And so it's not really like a airtight volume, but it is something where there's enough air sort of flowing through it to give it a shape. So in that continuous blower example, this is also super approachable. You buy one of these from little blower fans for like, I don't know, $5 or something. And you can get these actually beautiful, I think elegant, sort of macro scale shape changes. This artist is worth looking up if you're interested in these kind of DIY fun fashion projects. Dana Eng. Or like on the non-DIY side of things, these kinds of inflatables, this is a commercial product, is a rapidly inflating, essentially an airbag for your head, halfway between an airbag and a bicycle helmet. And the fact that they sell these, that their lawyers have allowed them to sell these, implies to me that this is a very repeatable and reliable motion, which I think is actually totally fascinating, because I don't think of, you know, when I see this one, it's like, oh, it's beautiful, it's elegant, but I wouldn't call it reliable. But, you know, hey, if you can engineer it very well, apparently it is actually very reliable. Okay. The other approach, this sort of sealed approach, I'm really not going to talk about very much because Luca's going to tell you about this in like a week. Ooh, sound, sorry. But you could do these sort of thermally sealed pouches and inflate them with just actually a little bit of air and do all kinds of interesting distortions that way as well, in ways that are maybe non-intuitive. But so that's your little teaser of the upcoming unit. And you're like, okay, Leah, but like, is this really fabric? This part in particular, it's really starting to feel like maybe it's not fabric. And I'm like, okay, I hear you. Especially like when we look at like these examples, they're mostly on rigid materials. And the scale of the airbag is such that it feels like a sort of whole additional extra object. And to that I say, yes, it is not itself a fabric, but remember, we can intervene at fabrics on like all kinds of levels, right? Fabrics have a hierarchical structure. You were saying maybe fabric, those pouches aren't like a fabric sheet, but what if you made them really small? They can be the fiber in a fabric, right? So this is a paper called On the Fiber, where they're using sort of a similar microfluidics approach. And then those fluid channels are the fibers that they're then weaving or knitting. They do both in this, both weaving and knitting in this paper, into a fiber that they, into a fabric that they sort of control in this way. Okay, which brings me to one last bit in this first section, which is the idea of responsive materials, which is actually the beating heart of this class. Because when I said up here, scrolling back up for myself, I should have put the slide here again for myself, you know, interactive system, input, output, there's probably a computer in the middle. There doesn't actually have to be, right? Like, okay, first of all, as sort of an artist and an architect, I would argue that literally every material is interactive. It's not necessarily planned interactive in a particular way, but if I punch a wall, the wall punches back. When we say responsive materials, we're talking about materials that still have maybe a slightly more planned or designed reaction from some kind of input, but doesn't necessarily have to actually have a computer shoved in there. So for example, you can buy a thermochromic dye, right? You can dye fabric, you can paint wood, whatever, with these pigments such that when they heat up, they change color. That's an input, that's an output. It doesn't involve a computer. You can do interesting things with that in ways that might involve computers. So this is a project where the heat source is computer mediated, but the sort of, on the material level, the material is responding to the heat. This video is also very beautiful and I recommend watching it. But the effects are very slow, which is actually kind of the point of the paper. Similarly, here are some fabrics that have been printed over with hydrogels. Hydrogels swell when you get them wet. So if you have a fabric that swells a little bit when it gets wet, it's going to curl and fold and stuff in ways that are not exactly just the linear response of the fabric underneath. So input water, output motion. No computer at this stage. Perhaps a computer involved in sort of how you planned where the hydrogels actually get deposited on the fabric, but not a computer here. Or sort of similar in a conceptual way, but much more fully worked through, this project that Linning did, where it's similar sort of moisture trigger. And then the underlying thing that responds to the moisture trigger is these little dead bacteria, dried nanocells, that even when they're dead will swell a little bit. Each one just swells a little bit. But if you're careful about how you design that little bit of swelling into the fabric, you can see here that the fabric is actually opening in response to just the sweat from the human body. So input sweat, output, elegant little motion. Okay. That is where I intended the break to be. So I don't know. So I think we should have a break, but we also only have 15 minutes left in class. That was the interlude for folks complaining about bodies, but not really complaining. I mean, I'm not. Yeah, this is very related. This is very related to what I want to talk to you all about. So we're just going to do the first little bit here. And I think I'm going to get the slides online like right after this class, so you'll be able to preview some of the stuff that I would have talked about today, and then I'll go over it a little bit more in detail actually on Tuesday. So what can we do with any of this? What can we do with all of this? This is actually a slide that I took from my e-textiles class. So this slide is a little bit more e-textiles focused than like actuation focused per se. But I kind of just want to point out that there are lots of overlapping communities of who thinks about soft interfaces, soft systems, whatever. There's lots of directions you can take this. A very popular one is reactive wearables. That's going to be kind of what I talk about for the rest of this. Soft interfaces, very popular, very cool, especially like in the video game community. There's all kinds of weird soft interfaces. And then almost entirely divergent from this, but also fascinating, computational exploration and sort of like textile fiber art. I'm going to zoom in on that one really quickly because it's a work you guys should know about. This is by Erin Apache. It's an embroidered computer. It's so different from anything else in this entire slide deck. These are handmade embroidered relays, which just blows my mind. This is a beautiful piece. It's a piece about computation. She's really exploring like what it means to compute electronically in a system with this just like incredible level of handcraft. So this is also under the umbrella of soft interactive systems. This work exists in the world. But what I actually wanted to sort of focus on for today, Leia, is this body as sight, right? So one of the reasons I love fabric, one of the reasons you might love fabric, is that it is a really great material for bodies, right? It's what we surround our bodies with for a reason. It is soft, typically. It is breathable, typically. Our technologies for making fabric are literally 60,000 years old, right? So we've been at it for a very long time. We're comfortable with fabric. We believe we know it. It still surprises us sometimes, but it's a familiar and intimate material in that sense. There are on-body works that are not clothing. I don't know. I don't like to draw a bright line here, but I would say that this is work in the direction is a sort of more further from being clothing per se. This is great work as well, though. So this is work about making little swarm robots that attach themselves to your clothes and do these cool on-body interaction stuff. And this work talks about like, what would you even want a swarm of robots to do on your body? Why do we want robots around our body? Getting a little bit back more towards clothing, this is another diagram from that same paper I showed you before by Vanessa Sanchez, where she says these are some typical use cases that she has come across in a lot of her research on e-textiles and soft actuation. So these are like things you're going to come up across a lot. So dressing assistance, especially like in a disability context, right? Somebody who has a limited range of motion as compared to a normative body. Locomotion assistance, again, particularly you'll see this in like rehab, but also in contexts like extreme sports or mountain climbing or whatever. Grasping and reaching, again, extreme sports, also factory settings, things like that. These are like, let's make humans more efficient, which I've got opinions about, but capitalism loves this. Thermoregulation is the OG thing that clothing does, right? And so we can do interesting things with how clothing does thermoregulation. Haptics and communication, right? Maybe our clothes are telling us specific things linked to the outside world. And therapeutic compression is kind of like the locomotion and dressing stuff. It's often used in a medical context. But also can be used for things like VR, right? Like things like, oh, this is a specific sensation at a specific time. This paper is so good. It's only like 10 pages long and it's jam-packed, let me tell you. If you're interested in the space at all, I really recommend it. So this is a diagram from a workshop paper that I submitted with my colleague David Perry, where we were trying to talk about, okay, you say you want clothing that is a robot. What even is clothing? Like, let's talk about what clothing does. I think clothing does a lot of things. This is just a really sort of simple diagram we threw together in an hour, but it starts to get at it, right? What does clothing do? Temperature and humidity regulation, abrasion, skin irritation. You know, these are the sort of like reasons you have to wear clothes other than legally. These are the reasons it feels better to have your body in the world surrounded with clothes. It kind of protects you in these ways. It can also do like task specific things, right? Like if you're welding, you might need big padded gloves, you might need your welding mask. Even if you're bicycling, right? Task specific things like you want extra flexible knees and things, or you might want something that's very reflective because you don't want to be hit by a car, things like that. So there's a sort of task specific safety things. Also storage attachment points, right? Pockets are great. Things you can clip your carabiner to. These are all wonderful. And then there's this whole category of stuff that clothing does socially, right? It mediates your experience of the outside world, what you can see, how you feel, right? It feels very different to wear a very puffy skirt. If you've never done it, I assure you, it is very different from wearing pants. It mediates how other people see you, right? What parts of your skin they're seeing, what associations they're making about how rich you are, where you're from, what your job is, all that stuff. So it is this constant layer of mediation between you and the world. And the world is a physical world, it's a logistical world, and it's a social world. There's a little bit of a distinction I like to draw here between clothing and costume. This is not a moral distinction. I'm not saying one of them is better than the other. They're both very interesting. I would say that clothing is something that a person wears and costume is something that a persona wears. So costume, therefore, is primarily about the observer's perspective, right? So an actor on a stage wearing a Cinderella costume is primarily using that as a tool to show the audience who their character is. It certainly shapes that actor's experience as well. And I know a lot of actors have a hard time getting into character when they're not in costume. But the sort of primary use of costume is the sort of outward, whereas I argue that clothing is really a true bidirectional mediator. Yeah, and there's not like a single narrative goal, right? If I'm wearing a Cinderella costume, I'm trying to convince you that I'm Cinderella. If I'm wearing what I'm wearing right now, I'm not really trying to tell you one specific story. I'm just sort of telling you about myself broadly in a sort of more subtle and ongoing way. Yeah, I think we gotta end there because we're at 11:28. But so those are the kind of thoughts I wanted to put into your head when we think about body as a site. Is that actually, sorry, hang on, let me tie that back to the inclusive thing because this was going to be a little more explicit later. But I had a lot of conversations with Linning about, what are we talking about when we're talking about inclusive? And I think a lot of what she was saying earlier, smoothing out the mismatches, right, between someone and an environment is a big part of it. To me, also a big part of it is specificity, right? That every person has their own specific and unique context. If we're not being inclusive, we often forget what those contexts are. Things like that person might be too short, or that person might need the light to be less dim, or whatever. These high-level things are things like, how they're racialized, how they experience their gender, all these things together mean that inclusive design, to my mind, has to account for these kinds of things. And the reason, a big reason I like to think about bodies and body as a site, body as a context, is that it's an incredible place to think about inclusion because everybody's body is different by definition. And this is where a lot of these issues of inclusivity come to a head, right? How does their body experience the world? How does the world treat their body? So many opportunities in this to think about opportunities for inclusivity, or thinking about personal and specific work. Okay, that was it.
This is a topic I believe will continue, right?
Yes.
Yeah. What is it? But I think Leah ends on a really exciting and important notes. Wearables, body definition, self-identity, inclusive. These are very essential topics to the class.